Hey, what's up, my GenXRant Nation? This is David, your host, and I'm talking again today about tech and gaming because they're kind of going hand in hand today. And I thought, because Xbox is really like raspberrying everything, why not talk about the competition PlayStation 5 or Sony PlayStation? Because they sure make it easy when they come out with some information and some good stuff about gaming, and it makes me excited for the future of gaming, not for Xbox. And as you guys might know, who have been watching my channel for a while here, I am an Xbox guy, but not so much anymore. Xbox has really turned the tide, so to speak, and made enemies of friends. So I guess it's time to say, the enemy of my enemy is now my friend, which is Sony PlayStation. Now, it's going to take me a while probably to buy a PlayStation 5 or 6 whenever that comes out, and really just, I guess, develop my gaming abilities on your guys' DualShock controllers, because this is so strange to me, but we'll give it a try. GenXRants here will give it a try. Good old, Gen X. We invented gaming, so screw you all. I'll be able to. So I'm going to talk about that a little bit today. Very interesting conversation between two individuals, and we're going to go right to that. Switch this up here so you guys can see. Make me small, I don't matter. So there's this interesting conversation. We're going to pause it at certain points. It's from it's called Project Amethyst. I hope I'm saying that correctly. And it's basically Mark Cerny, who's the developer of PlayStation 5, and he's been with Sony for quite a while, actually. The guy's an old school gamer developer. And from AMD, you've got Huynh. I apologize if I'm not pronouncing your last name properly, Jack, but let's go watch this video together and see what they're talking about.
We've been working on some seriously cool gaming tech with Sony, and I couldn't think of a better person to walk us through it than my good friend, Mark Cerny. Mark, thank you so much for coming out to Austin.
My pleasure.
I've asked Mark to join me to pop open the box and give you a peek at some of the gaming breakthroughs we've been working on together behind the scenes.
Yes.
All right, let's just pause right there. So right away, what is different, I would say, what's difference between what's going on here and what's been going on with Xbox? Xbox announced that they were working on stuff with AMD, but here, Sony and AMD are sitting down together talking about that technology. That's a big marketing difference between what words come out of the mouth of Microsoft, Xbox, and what is actually happening here with Sony and AMD. Let's continue to watch.
We've been busy, that's for sure. So today it seemed like it might be fun to share a bit about the brand new technologies being developed, starting with our collaboration under Project Amethyst to create the machine learning technologies of the future.
As every gamer knows, it takes a complex set of system expertise to get your setup and games to deliver the highest possible experience. As we progress together, the future brings us to real-time physics, cinematic lighting, efficient asset streaming, and keeping everything in sync across a CPU and GPU with super low latency. Trying to brute force that with raw power alone just doesn't scale. That's why we're combining traditional rasterization with neural acceleration.
Okay, so this is an interesting conversation to begin with, and this they're going to go into this deeper, but really we're hitting kind of like a tech limit, especially because of ray tracing. And I've mentioned this before. I'm not a big fan of ray tracing. I think it can be solved through different means. I don't think gaming is important enough, but if you're talking ray tracing with movies and stuff, if you're going to do some cool animated, it is an advantage to get that system in place where you're at least able to, get those calculations done very quickly. But we're hitting like a limit, if anyone knows, where ray tracing is literally bouncing the light off different objects, giving you proper brightness and shadows and things like especially with shadowing. And so it reflections, all of that. So you've got millions and millions and millions of rays. What God created naturally on the earth, from the sun reflecting off objects, which is not computed, it is natural, is completely, utterly complex. And we're talking billions and billions of calculations, if not millions on the low ball for a computer to make it look more realistic. That's why a lot of like skin textures and shadowing doesn't look quite right, and why the human eye can catch the differences, because we're so adept at it right now. So that's kind of what they're saying is like, we need some assistance. How can we make this process easier? Basically, let's go.
And machine learning isn't just a neat trick anymore. It's become a real tool for developers. Smarter pipelines, cleaner visuals, smoother gameplay, and more headroom to create the worlds we want to all get lost in. And that's what FSR is all about.
Okay, so FSR, let's talk a little bit about that. We'll jump over to... Actually, let's talk just real quick about Mark Cerny, who's from Sony. He was very familiar to me. I think I remember him from past game development, but just a heads up. So Cerny continued on as a lead designer of Sony's future consoles, including the handheld PlayStation Vita. So he had a part in designing that, and for the PlayStation 5. Oops. Cerny said that his consultant status gives him freedom that being an employee of Sony would not have, such as being able to work with multiple groups within Sony and the first-party studios for improving the PlayStation design. He also continued to consult in game design for several of Sony's first place. So he's a consultant basically for Sony. Probably lead designer, important consultant, since around 2009 and released PlayStation 4. Cerny has worked on a 2-year cycle. So he's a consultant, yet it's interesting that just a consultant is sitting down with AMD's head developers, gaming, and GPUs. But going into a little bit of what he means by FSR, at least. So if you have an NVIDIA card, I think it's DLSS. Put off the top of my head, but FSR is about, it's called AMD's Fidelity FX. So it's a suite of open source image upscaling and frame generation. I'm not a big fan of frame generation, but that's where we're at. The game engines are really outstripping or outperforming, because people, they don't want just 60 frames a second or 30 anymore. They want like 144. They want top of their monitor can do, like 328 hertz. Or frames per second. I want my card to do that too at 1080p, which is a little ridiculous. But FSR is basically frame generation technology, specifically by AMD. Of course, the game has to support it, but it's interesting. So it's rendering games at a lower internal resolution, then intelligently upscaling, again, intelligently, we're getting into AI, to get a higher output resolution, often delivering better visual quality and frame rates. So it's basically upscaling. Upscaling has existed for a long time. It's actually a technology that's been built in graphics cards for quite a while. Not at this level, and it's also been in TVs that were 4K were upscaling 1080p signals to 4K. You can turn it off, you can do smoothing, all sorts of stuff. Really good now, so it's built-in technology. But that's FSR, is specifically AMD's technology.
FSR and PSR actually come from deep co-engineering between Sony and AMD. Co-engineering the neural networks that power both technologies. And going forward, more and more what you see on screen, the detail, the fidelity, the atmosphere, will be touched or enhanced by ML. And that means we're not just hitting new technical benchmarks.
So ML is machine learning, aka people think it's AI now.
Getting closer to the vision of the artists and creators behind the games.
And the challenge comes in how we implement these systems. The neural networks found in technologies like FSR and PSSR are incredibly demanding on the GPU. They're both computationally expensive and require speedy access to large amounts of memory. It's
weird that they did that subtitle wrong. It said expensive, they said intensive. Just a note.
Nature of the GPU fights us here. It's made up of a large number of compute units, and problems are therefore typically broken up into bite-sized pieces to enable the individual compute units to tackle them. And there's a downside to that. Subdividing a problem can cause inefficiency, or even force us to give up and find a different approach.
Exactly. And that challenge got us thinking, and what came out of it is something we're calling neural arrays. Here's the idea.
This is a bit of a hype speak. I mean, because the world is so ingrained into AI, neural learning, and all this. It is somewhat similar to how the brain works. Neurologically, we have everything is sourced to a different spot in your brain. But it is more of a thing to say nowadays.
Instead of having a bunch of compute units all working on their own, we built a way for them to team up, to actually share data and process things together like a single focused AI engine. Now, we're not linking the entire GPU into one mega unit. That'll be a cable management nightmare. But we are connecting CUs with each shader engine in a smart, efficient way. And that changes the game for neural rendering. Bigger ML models, less overhead, more efficiency, and way more scalability as workloads grow.
Neural arrays will allow us to process a large chunk of the screen in one go, and the efficiencies that come from that are going to be a game changer as we begin to develop the next generation of upscaling and denoising technologies together.
With neural arrays, we're unlocking a whole new level of performance for ML, not just faster, but more capable. That means better FSR, better ray regeneration, and brand new ML power features.
You'll notice that because he's from AMD, he said ray regeneration is crazy. I think that's a slight make it noted that NVIDIA, it's a different. It's not a different technology, but just the way they think of it is a tiny bit different.
We're just starting to imagine, all working in real time, right on the GPU, and we're just getting started. As we look ahead, you also see dedicated innovations that bring cinematic rendering to an entirely new level.
Another area we've been focusing on has been ray tracing. When I look at its broad usage on PlayStation 5 for reflections, shadows, and global illumination, it's difficult to believe that it's been just 5 years since ray tracing was introduced.
Definitely, Mark. And now with path tracing becoming more central to real-time graphics, the demands on GPU just continue to grow. That's why we've been pushing hard to go beyond the current approach to help developers bring even more realism and cinematic lighting into their games.
But the challenge is that the current approach has reached its limit. To perform ray tracing today, a shader program has to juggle two very different responsibilities. One is ray traversal, digging through complex data structures to locate where the millions of rays being cast hit the millions of triangles in the scene geometry. When there are intersections, that same shader program has to also be doing its usual work of shading the scene, using texture and lighting information and the like.
And we spent the past 2 years rethinking the entire path tracing pipeline.
So I'm no expert when it comes to this type of technology. I have like an outer grasp of how a scene is put together, for example, by the GPU. You got the triangles, which are shaders, the textures, which are the wrap on or something, bump mapping, all this stuff that's been developed over 40 years of gaming, especially in the 3D space. And what they're saying and getting at the end of the day is how complex this is. Like, this takes a lot of compute power, and it helps when you can kind of have a technology, or this is where AI is great. AI is predicting ahead of time, in real time, or predictively, where especially the ray tracing path of that going to be, so that you can basically put less pressure on the GPU to do those calculations. It's interesting because technology has come where if you can do a shortcut and create that shortcut within the game engine or within the hardware itself, it saves a lot of computation power. If you study CPUs and instruction sets and all of that, that is the core, the great grandfather of all this technology, which is shortening the length or giving a shortcut, so to speak, to do the math on all this. And it's important because then the less you have to compute, or the more shortcuts you have, or the more predictive pathing you have, the easier it is going to be on the GPU. And the more naturally you get more frames per second. Because you want minimum 60 frames per second. I think the goal eventually, and I hope PS6 is heading this direction, is good 4K 60 frames a second, because most TVs especially, and I know some people do play their PlayStation 5s and Xboxes on monitors, but TVs are really meant, especially OLEDs and QLEDs, they're meant to do 120 frames a second now. Almost instantaneous refresh. There used to be this delay factor with LCDs. I think we've gotten past that, which is great. So, but again, this is all about how can we work together to create these shortcuts. It's an interesting conversation.
From hardware to software. Earlier this year at Computex, we introduced neural radiance caching, a key part of...
And just to stop for a second, I've never heard of this. Interesting, again, they're using that word neural. And I looked it up. So AMD's neural radiance caching is a machine learning technique, which is kind of what this video is about, part of the FSR Redstone technology. So this is really adopted into AMD's new GPU thinking. It's probably going to be in their next round of GPUs they release, the next generation, more prolific, that learn how light reflects in a scene to predict and cache indirect lighting for faster path tracing, ray tracing. It works by tracing a sparse subset of paths to train a neural network to predict. So as I said before, we want to get into the shortcuts, right? How it works, so path tracing and data collection. A traditional path tracer, so this is on the hardware level, render scenes, but only traces a small percentage, 2 to 3%. Part of that is because if it's not in the view or the privy view of the player, or it's the reason why you don't render the entire scene of anything, like behind the person and stuff. You only render what's in the 3D space visible to the first person or third person or whatever, the visual person of the game player, because you're not wasting resources. They learned this a long time ago, behind, down, what can be seen. So this is, hey, can we get that up a bit? Because it's crunching a lot of computational power. So neural network training, radiance prediction. And it was interesting how the AMD person had said, we're going to interconnect these to do a better job. And AMD's been working, that's why their CPU technology is so fascinating. The AM5, AM4s, ever since they went to Ryzen technology, that's kind of what they've been doing. They've been kind of letting the cores talk, and this is what he's talking about. Let's go back to
FSR Redstone. Now, we're building on that with Radiance cores, a new dedicated hardware block designed for unified light transport. It handles ray tracing and path tracing in real time, pushing line performance to a whole new level. Together, these form a brand new rendering approach for AMD. Radiance cores takes full control of ray transversal, one of the most compute-heavy parts of the process. And that frees up the CPU for geometry and simulation, and lets the GPU focus on what it does best, shading and lighting. The result? A cleaner, faster, and more efficient pipeline built for the next generation of ray trace games.
There's a significant speed boost that comes from putting the traversal logic in hardware, and a further boost that comes from having that hardware operate independently from the shader cores. On top of those performance increases, there's other features in the works too, such as flexible and efficient data structures for the geometry being ray traced. Overall, I'm really looking forward to the time when we can get Radiance cores into the hands of game creators.
And we're excited to see how developers push ray tracing and path tracing even further with these tools. And here's the thing, whether it's ML or ray tracing, they both hit the same bottleneck. Current GPU memory bandwidth limitations hinder the seamless adoption of next-gen rendering techniques.
I'm always fascinated by this comment about the bottlenecks. You'll notice that we've gone from like 300, or 256 was common bandwidth, like pipeline. And they've shrunk this last generation back to 128-bit. It always fascinates me. Pipeline, data transferability. That's a whole different topic, but it's interesting to look up the changes in thought process. It used to be when you limited that pipeline to 128 bits, or God forbid 64 bits or something crazy small, you can only shove so much information through that, right? It's like making the wire smaller. Pipe both. Interesting comment.
Requiring significantly more bandwidth to handle 4K plus textures and ray tracing denoising masks for smooth asset streaming. And that's where a final piece of news comes in. And yeah, it's a big one.
With current GPUs, including the ones in PlayStation 5 and PlayStation 5 Pro, we have something called DCC, or Delta Color Compression. It's a strategy that reduces the memory bandwidth consumed when the GPU is reading or writing certain data, such as textures or render targets.
And what we built for future GPUs and SoCs take the idea of data compression much further. We call it universal compression. It's a system that evaluates every piece of data headed to memory, not just textures, and compresses it whenever possible. Only the essential bytes are sent out, which dramatically reduces memory bandwidth usage. That means the GPU can deliver more detail, higher frame rates, and greater efficiency.
Here too, I'm really looking forward to what improvements universal compression will bring, and to what degree the effective bandwidth of the GPU will exceed its paper spec. There's a multitude of benefits from this, including lower power consumption, higher fidelity assets, and perhaps most importantly, the synergies that universal compression has with neural arrays and radiance cores as we work to deliver the best possible experiences to gamers. Overall, it's of course still very early days for these technologies. They only exist in simulation right now, but the results are quite promising, and I'm really excited about bringing them to a future console in a few years' time.
We feel the same way, Mark, and we're so excited to bring these innovations to developers across every gaming platform. Because this isn't just about silicon, it's about empowering the...
That's just Jack being polite. He said across everything. So it is a technology that AMD's developed hand in hand, probably with Xbox, game developers. They want to get their foot at one step ahead and just make sure they're making clear that this tech is not consolidated just to PlayStation, Sony, that it's going to be part of probably their GPU line. And I pray to God they start getting ahead of NVIDIA. NVIDIA, I have no comment on. I've not used NVIDIA for a long time. I try to avoid them. They're great at some things, but price to performance ratio is different. Anyways, that's a different conversation. But at least he's acknowledging that this is probably going to be, and watch my other videos, I don't believe there's going to be another Xbox. I'm fairly certain of that now. I wouldn't bet the farm on it, but I highly doubt it. And if it does come out, it'll be $1,000. But back to this conversation.
Creators and communities that make gaming what it is. And we're just getting started. As we continue building with close partners like Sony, everything we're doing is focused on one thing, pushing games forward for all of you. Gaming has always been at the heart of what we do, and it's never meant more than it does right now. We're here for the players, the creators, and the communities that make this industry matter. And everything we're building is for you. Thank you, Mark, so much for taking time to join me here today.
Thank you, Jack.
So that's pretty awesome. I mean, I'm excited. I haven't been excited about technology in a while, but really, it's not a coincidence. AMD and Sony sat down and got you excited and me excited about technology that's coming out, and this Project Amethyst that is basically hinting at, and Mark said a couple of years from now in PlayStation 6. I doubt that. I believe it's probably coming out next year at the end of the year. They would not announce this technology unless it was pretty much ready to go and ready to go out. Probably you're going to see it in the GPUs, at least a kind of I wouldn't say beta version, but it's going to be like at a lower level coming out on their next line of graphics cards. Probably next year is my guess. I mean, I haven't heard anything. That's just rumors. That's my guesstimations. That's my IMOs in my opinion. But it's cool, and I'm excited for PlayStation. I'm probably going off Xbox And as you guys all know, I haven't been working for 18 months. The Canada unemployment is out of control. That's a different conversation. My skills, it's hard to find a job. It's fine. I can't even get work at McDonald's. So I thought I'd just rant on the internet because, hey, why not? So are you guys excited about this? I'm excited about this. Comment down below. Like, subscribe, and share. Let me just put that up. Like, subscribe, and share, Boom. Join me on X. I'm at GenXRants SPD. And, join the Rant Nation. I appreciate you all. Take care and enjoy tech. Peace.